as symmetry. So this inner product should be a symmetric bilinear map that takes that maps two vectors of a vector space to the base field. Yeah. So the symmetry property will not be satisfied if you remove the last one. So if you have a minus here, it's called antisymmetric. Yeah, and you can express any bilinear product as a summation of a symmetric and an antisymmetric map. So that also comes because you can express any matrix as a asymmetric plus antisymmetric matrix. So something like that. Yeah. So you have this. So you have these three properties. So now if I take A1, A2, A3, B1, B2, B3 and I just add them as it is, does it satisfy your will it satisfy these three properties? Or do I need to take its conjugate? So the answer is you need to take conjugate. We normally take conjugates when we add. Right? So does it satisfy or does it not satisfy? Why would you need to take conjugates?
So we need to get a scalar answer. So we have to.
You will anyway get a scalar answer. Your set of scalars now is just C, right? The set of scalars is just C. So why will you not get a scalar answer?
Real, which is defined from vector space.
So you will need a scalar answer if you have to define a norm over this. If this dot product, if the inner product has to define a norm, then you will need a so a norm actually is even more. So if you have a normed thing, so it has to be a map of R, right? So if it has to be a norm is always an R. Yeah, so you will need that norm to go to R. So if you are just looking at a bilinear product, it may as well go to C. If the base field is C, it can continue to go to C. So if you're just looking at a bilinear product, it can go to C. Now if you want to have a bilinear product that defines a norm,